Hi, this is the second video for graphing relations. So let's talk about scale one more time before we get into reading graphs. So scale is kind of like if you have a party and you've got a rectangular birthday cake and you need to cut that cake up. If you have good scale, then the pieces you cut are generally kind of the same size. If you have poor scale, it means that some people get really huge pieces and some people get really small ones. It's kind of the same with graphing. We want to space out our numbers consistently on the grid to show that they have equal spacing to represent the patterns that they're showing. So just to use my highlighter, on the y-axis here, we're going from 0 to 10 using 2 grids. And then from 10 to 20, we're using 2. And from 20 to 30, we're using 2. So that's called good scale. That's very consistent. On the x-axis, we have great scale from 5 to 6, 2 boxes or 2 grids, 6 to 7, 7 to 8. That's all good. But notice that we go from 0 right up to 5, also using 2 spaces. That's allowed, but actually they should have something called the scale break there. Because what a scale break shows is we recognize that we're jumping, that we're using this spacing to mean more of an increase than the rest of the pattern. So in order to show that, we can put that little kind of lightning bolt symbol in there. Now this is a graph very similar to the one that you may have graphed, but of course we can graph things differently. They chose to go up by tens on the temperature or y-axis. And if we interpolate, if we look inside the graph for information, we can find information without having to do any kind of calculations. So when they ask you a question like, what temperature was it at 7 p.m., interpolating means you find 7 p.m. here, and you go upwards with your eye, you find the plotted point, and you look over on the y-axis, and you see that the temperature was 20 degrees. That's called interpolating or reading the graph. So interpolating is pretty straightforward, but sometimes we have to extrapolate. Extrapolate means we extend the graph, and we can even use the equation, which we'll practice. And that's a way for us to predict unknown values. Now, if you remember, our graph finished over at 8 p.m. And so we could then either continue to draw if somebody asked us what temperature will it be at 10 p.m., or we could let our eye go down, kind of draw with our eye, and then see that we hit a temperature of 5 degrees. Extrapolation using a graph sometimes is quite tricky. Remember that you always have your table of values when you have a graph, so you're always able to either increase on your table or use the equation to extrapolate perfectly. So extending the graph is one way, extending your table of values is another way, or using the equation from your table of values to substitute is another way that you can come to the right conclusion about what temperature it will be at 10. So we can practice interpolating and extrapolating in this student example. The graph shows the relationship between the length of a long distance call and the cost. So the time is on the x, it influences how much money you're going to spend. Question A says, if Becky talked for 2 minutes, how much would the call cost? Well, we can interpolate this because we see right here that we have 2 minutes on our graph. We can look up to the plotted point and over, and we can see clearly that it cost 60 cents. For B, if she talked for 8 minutes, how much would the call cost? We see we have 8 minutes, but when we go upwards, we see that the line has not met that far. So we have some options. Because this graph is pretty straightforward, we can draw upwards, and we probably will be able to extrapolate that way. So we can create the line or extend the line a little bit, and then we can move our eye backwards and see that that call is going to cost 120 cents or $1.20. I'd like you to notice the scale break on this graph right here in the corner. This means that they use 2 grids to go from 0 to 40. That's a plus 40. But then after that, they use 2 grids to go up by 20. And from there, they use 2 to go up by 20 consistently. So to show that they have a break in scale, they use that scale break symbol on the y-axis. Question C says, what is the base amount per call, no matter how long it is? So how much does the cost call even if you are not spending any time? As soon as you pick up the phone and dial that number, you can see that at the time of 0, you do have a charge. You have a charge of 40 cents. This is our base amount. So it begins on the y-axis at 40, not down at 0. Not all graphs have to go through the point of origin. In fact, most don't. So we have a base of 40 cents, and then the price goes up per minute after that. For D, we need to write the relation between the length of the call and the cost. So what they're asking us for here is the equation. In order to make an equation, we should make a table of values, and we only need to make a few values in order to create our equation. So when x is 0, y is 40. When x is 1, y is halfway between 40 and 60, which is 50. And when x is 2, y is 60. Now we can see our pattern. X is a plus 1 pattern, y is a plus 10 pattern. We are going to create our equation now. Y is equal to, remember calculating our slope, change in y over the change in x. Slope is 10. Y is equal to 10x. And we try that. We multiply 0 times 10 is 0, so we have to get up to 40. 1 times 10 is 10. We have to get up to 50. Our bridge here is plus 40. And that makes sense. 10 cents for every minute plus the 40 cents for the base means we are going to get the price for this long distance call. The last part of this lesson is looking at the coordinates. So we're looking at all 4 quadrants here on a graph. And so we just need to put the ordered pairs for each of these points, A, B, C, D, and E. So we just need to be very careful about this. When we're doing each of these, we are starting at the point of origin, and we are letting our eye move to the X and then the Y. So A is at the X of 2. So I'm just going to put A is equal to, I'm going to use brackets for my ordered pairs. So 2 comma, and then I look up. That's at a 3. So I'm just using my highlighter just to show where my eye is going. So this is 2 comma 3. B, it's at a negative 1 for X and a positive 2 for Y. So I make my ordered pair, negative 1 for X, comma, positive 2 for Y. For C, I'm looking over, it's at negative 2 for X and negative 2 for Y. It's negative 2 for X, comma, negative 2 for Y. For D, I'm at the positive for x, 3 for x, and down to 2 for y. So this is going to be positive 3 for x and negative 2 for y. And lastly, E, that's right on the line. So that's going to be a 0. Just use a different color here. That's going to be a 0 for x. I'm not moving left or right. I'm staying there, and I'm going down 1. So that plotted point is going to be 0 for x and negative 1 for y. You can also have questions like this student example, which point is indicated by each of the following ordered pairs. So we're looking for negative 10 for x and positive 10 for y. So we're going over to the negative 10, and then we're going up to the positive 10 for y. So our plotted point there is going to be A. And then when we go ahead for our next one, 15, 5, we're going to positive 15 for the x and positive 5 for the y, that's E. And then our last one is 0 for x and negative 5 for y, so that's point D. When you get to the exercise and you are faced with graphing, remember that you can express relationships in the 3 ways. You can create a table of values or use a table of values. You use the points on the table of values to plot on your graph, and you can create an equation from your table of values. Your scale on your graph is very important. Make sure that when you have your numbers, because your numbers follow a pattern, the spacing on your grid needs to be equal to represent the patterns that you see. You get to decide how to space things out. There's no perfect way. And if you find that the book's graph paper is too small, you can use your own graph paper to give yourself more space to create your graphs.